So today I solve numerical. Okay. So exercise 2C concise plus 10. Okay. ICSE Physics. So previous lecture we discussed the theoretical portion. Okay. Verify the uh, theorems like uh, conservation energy theorem, principle of conservation energy. Okay. So verify this theorem. And now I solve the basic numericals. Okay. So question number 2, concise, okay, books concise. A stone of mass 500 gram thrown vertically upward with a velocity of 15 meter per second. Calculate the potential energy at greatest height. Okay. First we draw a diagram. Very important. If I draw a diagram, then solving the numerical is very easy. Okay. First, try to draw a diagram. It's not a free body diagram. Okay, this is a diagram. So stone of mass 500, that's a stone. This is a 500 gram, 100 gram, vertically upward. So velocity is 15 meter per second, and the potential energy at greatest height. So I think stone goes that height when that is a ground, and at that height, okay, at that height the potential velocity being 0. Initial velocity 15 meter per second. What is the potential energy at greatest height? Okay. So mass is given, that is 500 gram. Now it's converted into SI unit. So that is very easy. So suppose the gram to convert in kg, 500 gram, and you know the 1000 gram equal to 1 kg. So 500 by 1000 kg, and if you can this, let's do 1 by 2 kg. That the mass of the stone. Okay. If a stone vertically upward, so what is the potential at that height? We know that potential at that height is maximum. Okay. And total energy formula, you know that is that kinetic energy plus potential energy, that is equal to total energy. But at that height, potential energy is maximum, but kinetic energy is 0. Okay. Suppose if I at bottom point, we also know that potential energy is 0, but kinetic energy maximum. But we know that the potential energy at top, that's also equal to kinetic energy at that bottom. Okay, that's also equal. Potential energy at top, that's also equal to kinetic energy at bottom. So potential kinetic energy at bottom dot that's also equal to potential energy at top. That is equal to very familiar to half m v square. Know that half mass is 1 by 2, velocity is 15 square. And know that the 15 square is 225 divided by 4. That is 225 divided by 4 is 4, 5 20, 2, 5, 4, 6, 24, 0.04, 2 is 8, again 2, 0, that is the joule. Okay, so here the answer is 5.26 joule. That is the first answer. That is very important. Key point is here, potential energy at the top, that is equal to kinetic energy at the bottom. Okay, now solving the next part B, the kinetic energy on reaching the ground. Also same, we told that here the kinetic energy at the bottom, that is also equal to potential energy at the top. So part 2 answer also be the same as part 1 answer, 56.25 joule. Okay, the total energy at halfway point. Okay, that's the important point. At half point like this, at midpoint. Okay, the total energy. Okay, we know the conservation energy principle. The total energy always fixed, a constant. If total energy at the top also equal to total energy at a midpoint and also total energy at the bottom, all are in same. Okay, so that's we know that if I calculate total energy at midpoint, we do not need to calculate kinetic energy plus potential energy, then added these two and you get a total energy. But we know that the principle of conservation of energy, the total energy is always constant. Here the total energy is 56.25 joule. Okay, the same answer. Very easy. Because we get from principle of conservation of energy. Get this. Okay. Now, question number 3. The metal of ball mass 2 kg allowed a free fall or a rest from a height of 5 meter of the ground. Okay. First, we draw a diagram. That is the highest stone or mass of ball, that is 2 kg at top of the building. Height is 5 meter. That height is 5 meter. G also given here 10 meter per second square, that is a second square. Okay, second square. So first we calculate potential energy possessed by the ball when it initially at rest. I think top of the building, the potential energy, top of the building, that is also equal to kinetic energy at the bottom. But here do not know the velocities. Okay, so potential top, that is equal to mgh. So mass is 2 kg, g is 10 and h is 5. Basic potential energy formula P equal to mg. To a 10, 10, 100 joule. That is a part 1. Part 2, the kinetic energy of the ball just before hit the ground. Just before hit the ground, I think that point. That's the key point. Okay, previous numerical discussed the kinetic energy at the bottom, that is also equal to potential energy at the top. So that is the potential energy of the top is 100 joule. It is also equal to kinetic energy at the bottom. It is also you get 100 joule from principle of conservation of energy formula. You know that. Number B. What happened to the mechanical energy after ball hits the ground can comes to rest? That's important point. Can the ball comes to the rest? Okay. Okay. That's important. If a ball hit the ground, ball hit the ground. Okay. Now, what is the mechanical energy after ball hits the ground? The mechanical energy, some is converted. If a ball or stone hit the ground, they just produce a sound energy. Produced sound energy. We know that if I throw a stone and stone hit the ground, so there get some energy, sound. Okay, that is the sound energy. First conversion energy, sound energy, and another conversion of energy is heat energy. If some stone hit the ground or hit any other object, there is a friction. Okay, so that friction gets some heat form. That is a heat energy also. So there is a two type of energy. One is heat energy, another is a sound energy. That's part B answer. Okay, next. Question number 4. The diagram given below show the ski jump. A skier weight is 60 kg. Stand on the top of the ski. I think here. Ski jump, and he moved A and takes off of his jump at B. Selena solution. I think there's a given. Okay, so yes, just ignore that part. Okay, that is Selena concept. I think I erase the hint. Okay, now I try to solve this. Okay, okay. Calculate the change in gravitational potential energy of the sphere between A and B. So gravitational potential energy, you know that at point A, we get a potential energy means mgh, basic gravitation potential energy formula. What is the m? 60 kg. G also given 10 meter per second square. Okay. That is a 10, and here the h is 75. That is 75, and we get 75 times 6 is 75, 225, 2 sorry, 3 is 225, sorry. 75 times 225, 450. Then 75 to the 150, sorry, 450, and 20, that's true. So we get at 45,000 joule. Okay. Now, what is the part B potential energy? So part B potential is also there. What is here comes the part B. We get also the mgh, 60 times 10 times h is 15. 15 6 90. So what change or gravitational change means difference. So that the difference is a change that is equal to 45,000 minus 9,000 joule, and we get 36,000 joule, means 36 kilojoule. Okay, that's it. So that's the part 1 answer, 36 kilojoule, the change. Now part B. If 75% of energy in part A becomes the kinetic energy at part B, calculate the speed of the sphere and arrive at B. So 75% of energy in part A. So here I think part A means like this, A point. Okay. So 75% of energy of part A, energy of part B. So 75% of part A. I think the part A means here the part 1 answer. So 36 into 75 over 100, that is kilojoule, 10 to the power 3 also. 20 here comes a 10. So 36 times part A. So 36 times 75. 75 times 36. So 6 5s are 30, 0, 3, 7, 6 are 42, 43, 2 plus 3, 45. That is 225, 0, 0, 4 plus 2, 6 plus 1, 7, 2, 7, double 0, and another 0. So 2, 7, triple 0 joule. Okay, that part of energy convert into kinetic energy. So the kinetic energy formula that is equal to half m. We know the mass is 60 kg. V square don't know, that is equal to 27,000. So it 0 0 cancel here. So that is a 3 3 9 is a 27. So V square equal to 900 and B equal to 30 meter per second. So that is the part B answer, 30 meter per second. Okay, that's very easy. Now question number 4. And next question number 5. An hydroelectric power station takes a water from a lake. Water level is 50 meters above the turbine, assuming the overall efficiency is 40%. Calculate the mass of water which must flow through the turbine of each second, produce output 1 megawatt. Okay, so calculate the mass of water. Okay, very easy. So water level is 50 meter above the turbine, efficiency is 40%. So here the efficiency for the turbine is here, very easy. So a potential energy, that is equal to mgh, that is m not given here, g10, that is a per second square, and height is 50 meter. So that is 500 m joule. Joule, that's not, that is potential energy, not power, that is a joule. Okay, so efficiency is 40% to calculate the mass of the flow. Okay, mass of water flowing through turbine each second. So 40% of 500 m. So according to problem, 40% of 500 m, that is a 1 per second, that is a work done. Okay, potential is also work done. By time in 1 second, by time in 1 second, that is equal to 1 megawatt. Mega means 10 to the power 6. That is energy by time, you also get a power. Okay, so very simple. So 40 by 100 into 500 m, that is equal to 1 2 3 4 5 6, 2 0 2 0 1 0. So we cut this 5. So 5 to the 10, 1 2 3 4, 2 3 4, that is a 20,000, and here 4 5 20, 1 2 3 2 3. So m equal to 5,000 kg. Okay, so mass of the water is 5,000 kg. Very easy question. Okay, that's the important point. When you solve a numerical problem, first read the question very carefully. Okay, very carefully, and then mark the key point. Okay, key point of that numerical question. Key point or marking the data was given here. Then we try to understand the question. Okay. After understanding, then we think which formula we can apply that numerical. After you find the formula, just put on the data and get that answer. Okay, that's very easy. Next question. First, very important point. First, I read the question very carefully. Okay. Next, a bob of a simple pendulum is imparted a velocity of 5 meter per second at a mean position. What is the maximum height or rise reaching at extreme position? 60% of the energy lost overcome the friction of air. Okay, velocity is this. The mean position means a mean position. Okay, so the rise that reaching the maximum point is 60% energy loss due to the air friction. First, we calculate the energy. Half m what to the maximum vertical height to raise the reaching extreme point. Okay, when it is mean position, total maximum height of the will raise to reaching the extreme position is 60% energy lost in the friction wave. Okay. So first we need to calculate the height. What maximum to what maximum height. Okay. So kinetic energy half m doesn't given here, that is a v square. We know that v is 5 square. Okay, so extreme 60% energy is lost. To get that 40% of that height, 40% of that converted into potential energy, that is mgh. That's a basic question. That's the kinetic energy. 40% of kinetic energy is converted into potential energy. 60% is lost. Cancel this to m. 25 by 2 over 100. G means 10. H now calculate. So I think 0, 0 cancel. 2 to the 4. And here 2, 5, 5, 5. Now 5 times 2. So 1 by 2 equal to h, and h equal to 0.5. Half. Okay. So 0.5 meter. Very easy. Okay. Basic numerical. So you complete the chapter 2. Okay. If any doubt in any portion, put in comment section. I will try to give the answer. Okay. Thank you.